Hi, I'm John Ritter. I'm a geologist. I teach at Wittenberg University in Springfield, Ohio, and I also work with the Soil and Water Conservation District here in Clark County. Today I want to talk to you about weathering and erosion, making the distinction between weathering and erosion. And both are significant, important to the landform we're in here, a gorge. We're in the Mad River Gorge, and you would not have this gorge were it not for weathering and then erosion. So we're going to distinguish between the two today. So, like a lot of things, to erode a gorge as deep and as wide as this is, we do it a step at a time, a rock at a time. You don't just cut it out and move it downstream. You actually weather it first into small pieces and then erode it, transport it away. So we're going to talk a little bit about weathering. And the rock unit here is dolomite, which is a carbonate rock, so it dissolves in water. And you can see the evidence for that water dissolution in some of the pock marks. Some of these holes here, they've been dissolved out of the rock. That becomes dissolved cations and anions that move downstream with the water flow. But that's not really how the gorge itself formed. Entirely. It weakens the rock, and once it weakens, it'll fall and then it'll weather more until the river can actually erode it. So there are two different types of weathering. One is chemical weathering, the other is physical weathering. Chemical weathering alters it. In the instance of dissolution, it dissolves it. That's changing the rock to a dissolved species. Physical weathering simply makes it a smaller rock. So we can see some smaller rocks being formed from the bigger rock here, and those will pop out by physical weathering processes. So things like the freeze-thaw activity that would create a pothole. That water would freeze and expand, and it would push some of these smaller rocks out. That's a physical weathering process. You haven't changed the rock. It's just a smaller piece of the rock. Other types of physical weathering, if trees start to grow on top and the roots grow, they'll grow down in fractures, and then they'll eventually grow and push that rock apart. So some of the bigger boulders here that we'll see a little later on, those are due to physical weathering of this cliff face. The chemical weathering, like I said, changes it, and there are several different types of chemical weathering processes. The dissolution, dissolving of that rock, but there's also hydrolysis, where you change the rock into clay and you start to create soils. There's oxidation, which oxidizes any of the iron-bearing minerals and turns them red, just like rust, which is really similar to oxidation. So we're going to look at weathering products down the slope a ways, but it's just important to realize that a cliff like this forms over thousands of years. But it's forming every day, every time it rains, every time it freezes and thaws. So it forms very incrementally, and you get the big change over many years of time, geologic time. So now we're down a little deeper in the gorge, and you can see the large boulders off to the side here. They've fallen off the cliff base where fractures have weakened the rock so that they can fall. Now these are still too big for the river to move, the river to erode. So they still have to undergo additional weathering, and some of that additional weathering will be physical. You've got trees growing on some of these, so the roots go down and start to push that apart. But a lot of it's going to be chemical. So they'll sit in close contact with the soil, and actually, because it stays moist, it continues that chemical weathering of the rock, and that's actually results in the soil. So we're on a nice slope here with big boulders called a collubial slope, and it's just what's gathering at the base of a slope. But it sits here and weathers, and I want to show you some of the evidence of chemical weathering. Okay, I've got a soil core here. I'm going to take a sample of the soil just to show you some of the weathering properties as you break down the big boulders into small pieces that river can transport. So I'm going to take a sample. And this just takes a nice pristine core of the soil. And then you can start to see some of the color differences. And I'm going to shave this off just so we can really see some of those. So you can see at the surface it's dark, and that's that organic matter that we use to grow our food in. But as you go to depth, you're picking up some of those earth tones, the browns and reds. And that brown and red is also clay, so that'll smear out where this won't. So you've got a reddish clay here, and those are weathering products. They're created by chemical weathering of the rock. So part of that is the oxidation, that gives it the red color. And then the clays themselves are formed through a process called hydrolysis. So we've seen evidence of the solution weathering, the cavities up there. We've seen evidence of the clay production, the hydrolysis. We're also seeing the evidence of oxidation that turns it red. All three of those are making the big rock smaller. And by making it smaller, it becomes transportable by water. And so we've talked about weathering. When you're able to move it away by water, that's the erosion piece of this. So we're going to look at one more site where we examine what the end product is, how the river actually creates the gorge once the weathering is complete. It starts to transport that material then out of the area, hence the gorge. So below the clay, you'd get more of the sand and gravel size material. And from sand and gravel to clay size, that can be moved by the river. So we're looking at a bar on the Mad River. You can see the sand and gravel. The clay would be in the water itself and suspended. But that's sort of the grain size at which that river can now do the work. So the gorge starts by some of that cliff fall, creating the bigger boulders. The chemical weathering breaks those down into sizes that are easily transportable. That size then is eroded. So we've got weathering and erosion to create a gorge like we see today. So I'm a geologist by training. What I do as a geologist is study soil and water. My expertise is in really how landscapes change by moving water. So I started in the arid west looking at alluvial fans, which are right next to the mountains. You'd erode the mountains, you deposit the fan right below. That's done in climatic pulses. It's done as climate changes over time in pulses. When I moved into Ohio, I started to study river systems and how they move sediments to erode gorges or landscapes like we're in today. That necessarily involves soil development because you don't move a mountain at a time. You move it particle by particle by particle, and that's that weathering process. So my background is in soil and water, geomorphology, the shape of the land, but I am a geologist.